So now let's take a look at our Somatic PDM EDD configuration. When you have your EDD loaded, you'll see all of your parameter lists come up, and you can go to your device menu and you can do an upload from your product to your EDD, or you can do a fresh download to your device if you've changed anything or if you want to wipe it back to defaults. First thing we're going to do is go into the security menu and enter our user PIN. This is the same PIN that the device comes with. You can find that in the manual, same expert PIN as well. So after that, what I like to do is go in and enable Echo Profiles. It takes about a minute to load up. So while you're configuring your device, your Echo Profiles can be ready and just help save a little bit of time. Like I said before, we recommend that the units wizard be configured first because that's setting your units for all of your different length, volume, and flow measurements. If you're not concerned with a volume or flow application or totalizers, you don't need to worry about those settings, but you certainly do need to set your length units and your temperature units. So once that's done, then we can go to our device menu again and our Operation Quick Start Wizard. When we open that up, we're going to see whether you want to configure 0.1 or 0.2, and if you would like to do a level, space, distance, volume, or flow application. You can also set your tag information, a descriptor, a little bit of notes for the device here. I'm not going to enter anything. We'll just move on to the next step, but that is available in the Operation Quick Start. Select your sensor, your response rate, your material type, liquid or solid. Enter your lower calibration and your upper calibration point based on your application. And then we can see what the old values were in the EDD and what the new values are. And as soon as we hit transfer, that's going to configure the device. Once a wizard is done, we don't need to go to the device menu and do another download to the device. As soon as we hit transfer, that step happens automatically. So then for pump control, we can configure sensor 0.1. In this case, we don't have any relays assigned, so we don't see that indication. We can choose how many pumps we'd like to configure and what mode we would like to use. So I'll stick with alternate duty assist here. For pump 1, I will assign it to relay 1. For pump 2, I will assign relay 2. And then enter our on and off set points. So for pump 1, we will turn that on at 4 meters, and we will turn it off at 1 meters of level reading, and pump 2 on at 5, and the same off at 1. Again, we can see the old values and the new values, and we can transfer to our device. Now, anytime you complete a wizard, you will get a dialog that comes up that says it's been completed successfully, just to ensure that you know that things have been set properly. So then we can go in, and if we want to do basic control, again, select your input. We can see now that there are 2 relays already configured, so 1 and 2 are assigned. So we're going to configure 3 and 4 here. What your on and off set points are for 3. So we will turn on a relay for basic control at 3 and off at 1. And what's nice about basic control is you can essentially enter anything here. So I'm going to turn on at 2 and off at 4. So I'm going to kind of swap where my on and offs are. And again, I can see what's changed and transfer to the device. So that's completed successfully, and now I can go and set up my alarms. Now this works a little bit different than the product. Again, we select our measurement point, but then we have to choose if we want our PV alarms, temperature, or diagnostics each individually. So I'm going to do my level alarms first, and I'm going to do an above alarm limit. And I'm going to set that limit for 0.1 at 5.5 meters with a 0.1 hysteresis. So I can see relays 1 through 4 are already assigned. I'm going to put my high alarm on relay 5. I'm going to select that option, assign the relay, and transfer to the device. Now if I want to set another alarm, I just have to run through the wizard again. So in this case, I'm going to assign a sensor diagnostic for an LOE alarm. Relays 1 through 5 are now assigned, so I'm going to put this one onto relay 6. Sensor diagnostics assigned to relay 6 and transferred to device. So there's my wizard setups. We can also do any of the individual parameter programming through the whole list, and you can find sections in the tree as well, like any of the typical EDDs that we have released in the past. If I go to the diagnostics menu and the device status, I can see every single diagnostic and alarm on the device, sensor, measurement point 1 and 2, totalizers, current output, and miscellaneous for all the rest. So quick indication of what's going on, and I can see I have a good status. I can look at my process values overview, and I can see what my level and my distance readings are. I can see that I have a good status here as well, what my sensor is, exact readings, and a couple of horizontal bar graphs. Under the dashboard, I see some more speedometer type dials, again for level 0.1 and distance for 0.1. And then I can go into the trend chart. Now, trend will only read while I'm in the EDD and while I'm in the trend view. So if you're looking for more of a data log, that'll be something that you have to retrieve off the micro memory card, but trend view is a nice maintenance view as well. So again, under the device menu, I can see the calibration log, the change log. I can go to simulation. I can look at my totalizers and see my maintenance schedules. The security, which we saw, I can do a restore point. I can restore from default settings, all from the EDD as well. Look at my peak values and do a complete device restart. So under the Echo Profile utilities, we've already enabled Echo Profile. So now we can take a look and we can actually do a measure on 0.1, and it's going to read all that data in from the LT500 now. So it's building the Echo Profile. And we can see that it's constructed it in our Echo Profile view, so we can close that and we can see our Echo Profile. We can look at the values, the confidence, the strength, what algorithm it's using. If there is any device status indicators, we can see we're in a good measurement range here. I can go in and look at any view saved Echo Profiles as well in the EDD. I can do a custom TVT shaping. I can do my auto false echo suppression from here as well. And I can set up my automatic echo profile saving. So any of the alarms or diagnostics that I want to drive saving an echo profile automatically, I can do. And if I want to do any damping or echo profile management, that can all be done here and then downloaded to the device directly. So that's the Echo Profile view. Again, very similar to all of the EDDs that we've done in the past. And a nice, nice diagnostic tool. So there's the EDD for the SITRANS LT500. The memory card of the SITRANS LT500 features several different functions. It can store data logs for all of the PVs selected, a parameter change log showing all of the different settings that have been changed in the device, backup restore point files, which also double as a parameter report, which can be viewed and printed and saved or emailed, an alarm or diagnostic log, a min-max log showing the min-max values of the selected PVs, the actual firmware file for the LT500, and also the ability to do firmware updates, a firmware change log recording all the changes that have been made to the device, and the instruction manual.
Once your application is set up, you can create a restore point to ensure that you have all of your settings saved. Under the Maintenance and Diagnostics menu, we can go to Restore Setup. In this menu, we can create a restore point. You can name the file whatever you wish. Backup is the default, and this file will be saved with a date stamp. Once the file is created, the backup can be accessed by going to the Restore menu. Even if you've used the same name for each, all files are date stamped, so if they are all called backup, you can see which one may be the most recent or the oldest. Once the backup file is created, it can then be downloaded into a PC and saved. It can be shared with another device to make configuration quick and easy on a multiple setup. Or it can also be used to create the structure for a setup where small parameter changes are needed, say in the lower cal or upper cal range. In order to access the files on the memory card, simply plug a USB cable into the service port and onto a PC. The memory card itself is found just above the cable and can be removed and plugged directly into a PC.
So here we have the LT500. It shows up just like an external drive. And I can go in and I can look at my restore file that I just created. So it's called backup. And I can open that up. And here we have a text file, which I mean is okay to read. It's got all the data that we just created. But what would be easier is if I open Excel and I go to data and I pull in from a text file or CSV type file. I can select my backup file and I can convert it into Excel in a much easier to read format if I just select semicolon and then go load. So there we get a much cleaner report, something that is fairly easy to save, to print out, to leave with your customer, to keep on file. And that is the backup file. So not only does it serve as a file which you can take from unit to easily configure your devices, but it also allows you to print all the parameters and settings that you have in the device. So if we come back, we can take a look at a data log file, and again, we can pull these up in a text format, and we can see all of the different values that we've been logging, and what we have available on the device. Again, you can pull this into Excel to make it a little easier to sort or to print. We have our alarm change log, which shows us all of the different alarms turning on and off. So again, we can see what's turning on, turning off, coming and going. And we also have our parameter change log. So this shows us what we have changed in the device, all the different parameter settings, and that allows us to audit what has been changed in a device, also what firmware has been updated. So there's a quick look at what you have available on the micro memory card.
So here we have a SITRANS LT500 fresh out of the box, and I'm going to do a quick start on a flow application. So measurement point 1, we're going to do volume flow, and we're going to stick with most of the defaults here just to do a quick little setup. We'll go to a fast response rate. And we'll use a rectangular flume, absolute. Approach width, let's say, is 1 meter. Throat width is 0.5 meter. Hump height is 0.1 of a meter. And throat length is 1 meter. Max head, 0 head offset, and low flow cutoff we can leave at the defaults, and we can apply that. Now on point 2, let's just do a basic level application. So meters as well, and yes, I've got an LU240 connected there. And let's just do a quick level setup so that we have some more values to show in our log. So now we've done our setup, and our device is now calculating flow. So I'm going to go through to my memory card setup, and I'm going to go to data logging, and instantaneous value versus an average value is looking at your logging frequency and whether or not you want to take the value when the log is being saved, or if you want to take the average of that value over the duration of the frequency. So for us, we'll stick with the instantaneous value. The logging interval is how often the log will be done. So we can see we have 5, 10, lots of different options for logging intervals, all the way up to 1 day, 24 hours, even in the milliseconds if we really want to get critical. 5 seconds will be good enough for our demonstration. And the process values. So on the first PV, let's do volume flow. Our second value, let's do distance on point 1. Our third logging value, let's do sensor temperature on point 1. And our fourth value, let's do the totalizer on our point 1. We can do up to 9 different logged values, specifically the PVs. And for logging value 5, let's go to level point 2 and temperature for point 2. For 7, let's do distance on point 2. And that should be enough. We still have 2 more values that we could log, but I think that'll show everything we need to for the purposes of this demonstration. Advanced logging is a menu that will only appear if you are unlocked in expert mode. And advanced logging allows you to log any parameter that the device has a Modbus register for, which is all of them. So we can see here that we have all of our different options selected for the different logging registers, but in 8 and 9, we don't have anything. So we can insert any parameter value we want here. So for example, in register 8, I'm going to put in the level 0.1 status, which is Modbus register 3487. And in register 9, I'm going to put the status of measurement 0.2, which is Modbus register 3488. And all the Modbus registers can be found online in the Modbus map. So now I am logging 7 different PVs and 2 different parameters. And like I said, you can log up to 90 different items. So 90 different parameters can be logged. What do we want to do with the behavior at full memory? We can either fill and stop or first in, first out. Fill and stop should work for almost any application. We can literally do hundreds of years if we're logging at like a 2-minute interval. Even with 9 PVs, it'll last quite a long time. So not a huge concern. The diagnostics, we have the defaults on, so when we have 7 days remaining of logging, we can raise a flag. When the memory is full, we can raise a flag, and those can be attached to relays as well if need be. For your log file, sometimes Excel in different regions uses a comma instead of a decimal point, so that option is in here as well for ease of use. And then finally, we come to enable our data logging. So as soon as data logging is enabled, you'll find that the other parameters are not accessible because if we change the log, we can't do that in the middle of logging. So anytime change is required, you'll need to disable the log and then re-enable it again. So we'll go ahead and we'll start our log, and we can see when we go back out to our display view that in the bottom right hand corner a little memory card icon is displayed, showing that we are in fact now logging data on the device. And we can see that our totalizer is running. Point 2 we're also measuring, so we're logging all the information that we just input. Okay, so we have our data log from our LT500, and I'm just going to plug in the USB cable, which connects the device, and it shows up as a USB drive. And in my LT500, I see I have a data log file. And if I open that up, I can see that I have multiple log files, and they are all date stamped, so the year, the month, and the day. And if you see multiple files, all that means is that the log has been interrupted or stopped. So the first file was the one I just tested and checked to make sure it's working. The second one is the one that I've just left for about an hour to run. So I'm going to open up that file, and there's the text log. And you can see I've got my volume flow, distance, all my different values, but it's not terribly easy to read. So we're going to go into Excel and open up the exact same file and sort it, which will make it a little more easier for us to take a look at. So if I go to the Data tab and import from a text file or a CSV file, I'm going to open up directly off my micro memory card on the LT500, which is still connected here. Same thing, the data log file and the log file, which you'll notice doesn't come up right away. We need to select all files, and there we have the file we want. So you're going to get a dialog box that asks you how to separate the data. And for our use, we're going to have a semicolon, and you can see it's going to be a nice and neat separation. So we're going to load that up, and we can see what our log file looks like. So our volume flow, distance, sensor, temperature, and totalizer for point 1, and our level and temperature and distance for point 2. And then we have our 2 Modbus registers that we did on point 8 and 9 for our data log, which are the status of our sensors, which a number 3, if you look at the Modbus map, both means they were in a good state. So there's all of our information, and we can see the units come through, what the Modbus register is for that particular PV, and the units, and then all of our data. And so from there, we're able to chart that data. We can do some graphs. We can analyze what's going on, and we can potentially troubleshoot or diagnose the problem. So there you go. Nice, quick, and easy way to get your data logs off of the LT500.